There we go. I'm here. And this week, I am first of all sorry for the delay. That's one thing that just happened. And, you know, it's a good thing there's nobody here. Otherwise, uh, people might be offended that I failed to show up on time. But that's okay. So, let me get all of my windows into place. Oh, what a week it has been. I'll start by giving you an update because if you are joining in, I am so happy with the quality of the latest interview that I've done. Oh, somebody's here. Oh, that's my streamer bot. So happy with the quality of the latest interview. I've like chippy chopped it all up. I've eliminated all of the pauses between words and it just flows so tight. I put it into my headphones. I listened to it overnight in the same way that I listen to any other podcast, and it was just like I know that it was me doing it, and so I have like a bit of bias in some way because it's coming out exactly like I wanted it to, but at the same time, it felt like a podcast that I would actively listen to myself. So I was so happy with it. And I will be so happy to be able to share it. And that's the story. So, on with the show because I want to knock my way through this really quickly. And so let's go. We want the desktop version of the live stream. We're going to quickly go through what we have here. Okay, and what is this? Simon Sinek. I was reading some Simon Sinek audiobooks as suggested to me by someone. So let's, what are we going to do? So this week, 19, 20, and 21 are there are a few tidbits. It's getting to the point. So let me switch off the desktop view back into solo and talk about what we're sort of seeing. We have a book club going on at work where every week we discuss the chapters and what's the story there every week with those chapters. Well, we've started discussing how we feel about what's going on in the reading and where we're going and how we feel. So it's getting to be a little bit repetitive in terms of reading through the whole book. I think I've said that once before. One of my colleagues today said if he was to summarize the book, it would be, if he was to summarize the book in 2 words, he would say it's just use interfaces. That's the book. That's the book. That's clean architecture. Just use interfaces. If another colleague at work, she had another take that was this is all kind of review. It's all stuff she kind of knows. It's all stuff that she got out of her CS program, and it's nice to be able to discuss it, but it isn't quite revolutionary. Now, that's really easy to say, and she fully admits this too. She says for her, she goes, for me, because I went through a CS degree program, this is none of this is new. And she says, don't get me wrong, it's a really great book, it's really great to know, but this is more intended for people like perhaps like myself who have come from a non-computer science background. I mean, I do have near 20 years programming experience, but I have never gone through a type of program where I've learned and read in detail about the content of architecture and the formal discussion of software design within an established mental model or framework, not in the programming sense, but in sort of the how do I think about things after 20 years in programming, and uh, by happenstance about 8 to 10 almost as having the job title of technical architect, one might think that I would know this stuff, and to some extent I mostly do, but I know it intuitively. And so even for me going through this book, I know that this is stuff that I've seen before, and it's nice to get that confirmation that this is roughly what I was expecting out of an architecture guide. There have been some things that have been interesting and new, and there's no question that I'm learning. But what is anyways, that's a long way. I guess that's about 5 minutes of saying so far the book isn't particularly new or revolutionary. I think a lot of it makes good sense in a way, but it's yeah, that's it. I'm happy that I'm going through it. I think it's worthwhile. I don't know that it's revolutionary, except for people who have never done something like this before, in which case this would be exceptionally good learning. I think what you would get from this, if you were a 5-year developer, or even in year 10, I think this stuff, I mean, even now I'm learning things that are new and interesting, and thinking of things in a slightly different way. So there's definite value to this, but I want to be transparent in terms of the level of praise the book gets, and the level of praise we should be giving it. And all of that said, there's also another wider debate about this particular book and the Robert Martin books in general, in that they are like Clean Architecture, Clean Code, is they are deeply opinionated books. And that isn't to say that all of the opinions are wrong, but there is a risk in going through something like, oh, Rajat, good to see you. And you're coming in from LinkedIn today. I love it. That must be so much nicer to not have to get off of the platform. It's really good to see you. So I was saying that there is a risk in reading Clean Architecture and taking it uncritically, and taking Uncle Robert C. Martin's opinions as the only correct answer. And even he caveats and nuances his answers as we go through. So it is not actually. I don't think Robert Martin says his stuff is the only way. I don't think any of us watching or reading along says that his stuff is the only way. And I really don't know of any people who are saying it's the only way, but one of the criticisms I have seen is from people complaining that other people put too much stock in this work, in this book. So, but I haven't seen any of the people putting too much stock in the book. I think every review of the book, or every discussion of the book I've seen, places it on a continuum of advice that you can take or leave. So that's a long way of saying. That's just a long way of giving my sort of ongoing thoughts on how the book is doing, and how the book is teaching us, and what we're getting out of the book at this time. So there's a story. let's get on to the content of this week's chapters. So, chapter 19 is called Policy and Level. He takes a moment to describe, he says, software systems are a statement of, are made up, they're composed of statements of policy, which means, or which is to say, a policy can be broken down into a smaller statement. And the smaller statement might be how the business rules are calculated, how the reports are formatted, how input data gets validated. These are policies, right? Now, the art of architecture, as described in the book, is said to be how we go about separating these various policies, the calculation of a business rule, the formatting of a report, the validation of input data. How do we go about in these policies separating those from each other in a way? I don't want to bump that microphone. I'm going to move that back a bit. So how do we go about separating those from each other? How do we go about grouping them together in the ways that they change? So your so everything to do with a particular given subsystem would change together on its own and in a group, and then you sort of, when they change together, you group them together, and when they don't, you separate them so that you don't get typically merge conflicts or things like that, or you don't run into problems. You break things out into, he says, one of the pieces of architecture that represents the art of architecture is forming your components, your groups of your policies, and breaking them apart so that they work together in a directed acyclic graph, which we have talked about in a previous week. You can go back to probably week 6 or 7 to get a really good overview of the DAG, the DAG, just like Brad Pitt in, what was that movie with Brad Pitt where he talks with a Romany accent? He goes, Dags, Dags. Anyways, super funny, probably a lost joke on everyone but me. Trust me, I'm laughing my brains out here. Okay, so the next thing that we talk about, so we break this chapter up into policies and level. So level is considered to be the distance from input and output. So the lowest level we get to is input output, and maybe there would be another tier above that of framework, data persistence, sort of details delivered on the web, delivered on a console. All of this stuff is really low level, mid level, and then the high level, the highest level that we can get to within a well architected system is the level of policy and business rule. And that's what we are going. I redid a bunch of his diagrams, and I just don't think that they add value this week compared to the other weeks we've had. And I think one of the things I want to do in terms of respecting your time as a viewer and our time as a whole in trying to go through the entirety of this book, which we're over. So this, it's not a tiny book. It's a large, hefty, big reading book. So I'm leaving out major parts of the things that are going on in the current chapter because the book is so very repetitive that I don't think I need to say the things that I've said again. And so, anyways, there are diagrams in this week's notes on the GitHub. You can look at them. I don't know that they add value, and we're not going to dwell on them. So the next thing, let me just read my notes here to see what else I'm editing out in real time. The reason for these designs is the fact that higher level policy, This is actually worth reading. So higher level, so we've just talked about how the low level stuff is the inputs. So you've got a mouse, you've got a keyboard. I accidentally just clicked something while I'm doing that, so I lost my notes. But you've got this. These are your inputs. I've got my screen up on the wall behind me. Those are my outputs. And those are both considered to be very low level. So what do we consider to be high level? The high level stuff might be something like the policy or the rules that go into the thing that you're designing. If I was talking about, okay, so now I am going to go to the diagrams, because we have something that can help make this concrete. So I'm going to go over to my desktop view. And if we look at something like an encryption program, we could draw a line right across here and call everything below the line is a low-level product. And then we go up a line, and our translation for our, so we send the character A into our encryption algorithm. We run a handful of business rules on it. So we run the algorithm, which could be, we all should know some things we could look up. There's an MD5 rule set for encrypting things, which is, there's a SHA-1. These are not good encryptions, but they are encryptions. And so there's MD5, SHA-1, there's RSA 256, and probably RSA 1024, and there's something called bcrypt. And each of those count as a much higher level. Those count as a much higher level policy, the much higher level component. We'll go back to solo because I don't want to dwell on this. And who's this? Chillcat. Adam Day, hello. Thank you for coming. And what is that? Chill with cat. I don't know that one. I bet that's a really good emoji, and I wish I could see it. Oh, my dream is shattered. But next time, I'm going to go look it up later. Thank you for emojiing me. So the thing is, if we're dealing with something like bcrypt on that, we saw that image of the translation layer. Say that was bcrypt. The rules for bcrypt change a lot less frequently than the method of getting our string of data into bcrypt. So that's why we have our high-level things that are separate from our low-level things. And it's about the frequency of change. So we're less likely to alter the algorithm to encrypt something than we are to change the way that the data gets into it. The higher level component will change for much more critical reasons. So it will be, if something happens, so let's say, like, I'm just going to think about this. So let's say we've decided to use MD5, a well-known bad broken encryption algorithm. We're using MD5 and we discover that it's a broken algorithm. So we say, oh, we've got to move it to bcrypt, right? The strongest currently known algorithm that I am aware of. And so that's a really critical reason, because if you're running on MD5, bcrypt is, if you're running on MD5, your encryptions are insecure, whereas bcrypt is still considered secure, to my knowledge. So the lower level ones will change more frequently. They'll change with maybe more urgency, but it will be less important than my data is not encrypted, right? It'll be, oh, I want to get it through an API. I want to get it through some other method. So lower, and so the thing that we've said before, and we're saying it again, is that these lower level components should be plugins for the higher level components. And that's it. And that's an entire chapter that we had to tell us the thing that we've already been told in like 3 or 4 other chapters so far. So that goes back to the thing I was saying about the book being getting repetitive. So the next chapter we have is called business rules. Now, the business rules are differentiated from policies in that they are said to be the rules and procedures that make a business save money or make more money, aka also known as profit. So the business rules are the things that make the company profit. These rules are said that these rules would generate profit even if you did them manually. So let's examine Amazon.com or Zensurance, the company I work for right now. So Zensurance has somebody's information about their insurance situation, and the business rule is if you take their credit card information, process it, and then cover them with insurance, then you're going to make money. And you're going to make that money whether you do it with a computer or not. The advantage of the computer should be obvious. The computer helping you do that 1,000 times a day instead of 5 times a day means you're going to make more money. There is the law of scale in this regard, but it's not important that the computer is there at all. And so this is the thing. You take these business rules and you separate them off into their own independently testable piece of the project, because so these are considered critical business rules. If something will make you money with or without a computer, make or save money. I mean, if something will produce profit with or without a computer, that is called a critical business rule. Critical business rules are often associated with data. The data associated with a critical business rule is called critical business data. Critical business rules and critical business data are inextricably bound. You can't, for example, the credit card number of your client is, you need that to process the data. You need the price that they're paying. Anyways, so one of the things that is suggested by the author is that we group these things, these rules and data, into objects that we refer to as entities. And I am going to bring up this image because I think it is pretty useful. So this is not insurance. This is a loan. So we have our loan data. The principal, being the amount of money you currently own, is a variable that sits on the loan. The rate of interest is a variable that sits on the loan. The period, or how frequently you have to repay the loan, is a variable. So you're going to group that beside some functions: make the payment, apply the interest, charge the late fee. All of those functions grouped with the loan data means that you cluster that off into its own component, meaning you can test that independently of whether it's delivered on the web, whether it's delivered on a desktop client, whether it comes through an API, whether it I don't like having anything in my recycle bin. I'm just going to empty that. 17 items. Oof, I've probably saved so much data right there. Anyways, so that's it. You group these things together because they are going to change, probably less frequently, but it will be more important when they do. And they don't want to have any awareness for any other part of the system. You can change the database, the delivery method, web, console, print it out on paper. Doesn't matter, just go for it. So not all business rules are entities. Some rules are around automation. So some of them create profit only by being automated. Some what kind of, I can't think of any examples of things that are only profitable by being automated, but I think what we would see is that all comes down to the cost of the implementation, right? Like even a Google search result would make money if you could do it manually for the right price. But anyways, this is not really relevant. So the use cases do not define the method of delivery. We don't need to see the notes here. I can just read through them. And you can always get the notes on the GitHub repo, so it's not important. You can follow along with the notes on your own. So it's not important that I have them on screen. So use cases are not defining the method of delivery. User stories define sort of a logical flow of things. So like an example of a user story, if a user, as a user, if I enter my personal information, the system can check my credit score so it can grant or deny me a loan, right? So that's sort of a use case. The use cases depend on the data, like that use case, get a loan, depends on the data, which might be a credit score, but the credit score doesn't depend on the use case. Use cases are therefore considered to be application specific. Anyway, and there you go. And so they can also be separate from entities themselves. So one of the pieces of guidance that the author gives says make sure that your entity systems and your high level systems don't send back formatted data. They take in raw data and they send out raw data. But if you want to transform that into a web format or something, do that somewhere else. Do that at a different layer of your program, at a lower layer. So business rules are the reason that software systems exist. I think that's fair. You wouldn't write a program for no reason. I mean, anyways, the business rules should therefore remain pure and have as few dependencies as possible. So it should be separate from your database. It should be everything. Business rules should sit off on their own. That makes a lot of sense, and it's really hard in practice to do, but there you go. They should be as independent as possible, and you should be able to write tests. Okay, so that's chapter 21. I started late, so we're only 25 minutes in. I think we're making a really great clip through 3 chapters, so I think you're getting this a lot faster than you would have to read it yourself. I can guarantee that unless you're a speed reader, because I spent a lot longer on this. So, the notes from edX. So, as you may recall, yeah, you're welcome. Yeah, I am putting in hours of work for you, Adam. I am happy to do it. I get a lot of joy out of doing this, but we are as I said off the start of the show as well, the book's getting a little repetitive and boring too. I'm gonna slog it through all of this, but man, I'm doing this for you. I'm doing this for you. I would have quit if I was reading this on my own for myself by now. I would be like, screw this noise, flip the table, I'm out of here. But again, I'm glad I'm going through, because every chapter has like a sentence that's worth reading out of 5 pages or something, right? So it's like you read through 5 pages and you go, oh, there's one interesting thing here, that one useful thing. So, I mean, sometimes I think this book could be a pamphlet, which I'm also, so here's another tangent. I'm thinking at the end of this entire book, what I might like to do is try and summarize the most important rules in like a 15-minute video so we can just boil down the entire book to only the stuff that matters. I think that would be really cool too. Maybe I do one, and maybe I do one with like angles and jump cuts and like, and it looks like a real YouTube video. Anyways, that's all me just going off on a tangent because I am crazy and talking to myself in my basement office. Okay, back on track. So I'm going to bring up my desktop again because these notes, I don't know if you are aware of this, but these notes come from the schedule. This is slightly modified from their schedule, but OpenEdX, they did a clean architecture book club in 2019, and they actually took a whole bunch of notes too, and they sort of, it's, I mean, this is highly tuned to their stuff. Anyways, that's all a story about what's going on there. And I liked these two lines out of the chapter, which is a long way. This is a very long way of saying, a 3-minute way of saying, great notes. Thank you, edX. And what does screaming architecture mean? So the title of the chapter is Screaming Architecture. Very, very catchy title. Well, what it means is when you open up your root folder of any code base, you should look at it and you should say, oh, I know exactly what this does. I know that this is, if you open up edX or OpenEdX, you should don't have a big collection of all of your apps together. Don't intermix everything. Have things co-located by the feature that they represent. So if you are doing edX, have a learning folder with learning associated apps. But maybe, so I mean, if we're thinking about the example of edX, maybe they also have a credit card folder or payment processing folder where they deal with collecting money. And maybe they have an issue certificates folder, I don't know, where they issue their micro degrees or the things that say, they might say Adam Day completed this course and blah, 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 right? So it's all about the idea. I'm not even convinced that I like this idea. I think it's interesting, but I'm not sure I've got my head around it yet. But it's what the book says, so you're hearing it here. I'm telling you. And there's some merit. There is some merit to it. So the thing that we're talking about is every software architecture project should have a theme. The theme exists to support the use cases. The use cases, again, like we just discussed. If we're at X, there is show the course. There's deliver the course. There is collect payment processing for those who sign up for the course and issue certificates for those who pass the course. So you're a database for credentials, you're a payment processor, and you're a course delivery method. So the architecture, a good architecture would make those use cases obvious. The first concern of any software product is that it is usable. And so really nothing else matters. I think that's a bit obvious, but I guess it's nice to be said. And that should be contrasted with the part of that doesn't matter, which is in a good architecture, it shouldn't matter whether you're on the web, on a mobile application, on a console app running on the command line, whether you're running a desktop app or whether you're pulling from an API. None of that should matter. What should matter is that you should be able to get what you're looking for and use it. So another thing that they say about that is if you are going to use a framework, so I don't know, raise your hands if you've used something like a mobile framework like Ionic or Cordova, or Flutter is I think the newest one, or Xamarin, or a desktop slash web framework like .NET Core, the .NET Core framework, or just the .NET framework nowadays. All of those things can sometimes, in some systems, begin to take precedence and importance over the fact that you are trying to deliver a product to your end user. So you want to do the job of making sure that your framework doesn't take over, that it is, again, like the edX example, learning. It doesn't matter that it's .NET. It doesn't matter that it's web. It doesn't, nothing matters but learning. And so those are some of the things. Now, there's another thing, and I've been particularly bad at this, and one of my future goals is to do another round of this stuff about unit testing in general, because I believe strongly in the value of unit testing and good automated software testing. I have not necessarily worked in places where I've been able to flex those muscles, but I've always strongly believed in it. And what was nice for me to see here, and if you tune into my upcoming interview with I tell you, so the engineer that I got this next interview with, he was one of the first 40 engineers building the Netflix streaming platform in about 2009. And so, like, what a really cool level of experience. And he is, I can't wait to share it with you. I can't wait to finish. I almost didn't do this show this week because I am so excited about the opportunity to share that interview that I just wanted to sit down and keep editing that. It's going to be so good. But he tells so many great stories. He's so self-reflective and introspective about his career and the way that he works and things. I learned a ton from him. And one of the things I learned, or I mean, I already knew about testing and I knew that it was important, but it was nice to have that validated after working in places where it just isn't really important to people. So anyways, back to the book, because we're almost done for the week, and I should respect your time. So, and I thought this was really interesting. So this incredible value that we get from separating our business cases, our business rules, our use cases, all out into their own module is, in theory, if everything up on that highest level is just a plain old object, there's no framework, no nothing, it's just plain old objects that maybe take JSON data comes in and JSON data comes out, which is to some extent formatting, but you'll forgive us that because everything needs an interface. Or maybe it's just object goes in and object comes out, right? Like, it should just be. But what we get from having something that is off like that is we can test all of our business rules in an automated fashion without loading a framework, without loading a database, without loading a web server. And each of those types of things is prone to bugs and problems. And there's no question that we do need to write integration tests, but the business rules are so important that if they have their own suite of tests up there on that very high level, we can, like, if you don't connect to a database, your unit test is going to run in memory, and it's going to run blazing fast. So you can have a very robust and strong and powerful and reliable test suite up on this highest level of your program, and you should have confidence that the stuff we described earlier as business critical, the business cannot survive without these rules in place. It's sort of like locking them in a vault almost, or like they're they're the golden child, right? They're just so important that we sort of lock them away. We lock them away and protect them from everything else. And it's a terrible metaphor to use with a child, but forget about that. So that's that. So honestly, here it is, the conclusion. Your architecture should tell the reader what the system does and not what framework you used. The reader of your code should be able to know what use cases, what should be able to know what the use cases are without even caring or wondering about what method this information is delivered back to the user in. So that's the story. That's the 3 chapters in, man, I bet you I did that in 40 minutes. Where's my, 42 minutes. We've been live for 42 minutes. We got all 3 chapters for the week. Next week is a vacation week. It's Thanksgiving here in Canada. So I am taking that Tuesday off to have a lovely family dinner. But we will be back the week after for chapters. Oh, let's bring this up. Oh, yeah. Yeah, I'm in Canada. Where are you, Hussein Webb? So let's look. So that was this week. Next week is... Oh, really? Where in Toronto? I'm legit right down. I am downtown Toronto. So, isn't that funny? What a coincidence. It's probably why I show up in your algorithm, though, because I bet you YouTube does, like, funny geolocation matching stuff to say, like, Mississauga. Okay. Yeah, we are really close. I am right downtown. Although I have been told by other people not to dox myself by saying exactly where, and I think that's probably a safe bet. Not saying that... Oh, okay. Okay. Yeah. RLS is, if anybody else is watching or reading this, Rand's leadership Slack is, and you can Google for it. I'm not going to bring it up here, but it's, I listened to a podcast today. It's got about 16,000 professional programmers in it, and engineering managers and leaders. They are spread across virtually every tech company you can imagine, and it's a very respectful community. A bit like there aren't really any arguments, or when argument, because internet is internet, but when arguments arise, they are just handled like adults, and people don't tend to flip out, and so it's really good for your... And they really support and believe in diversity and inclusion. So it's a mentally, like if it's a mentally healthy place to hang out, and the quality of the conversations that you get to have with the people, because, like, listen, and this is for anybody watching this who has made it 45 minutes into talking about clean architecture and software design. It's like, who's going to do that but other deeply nerdy people, right? Like, nerdy in the best way. We are like, we're nerds, we're engineers, we're just really into this stuff. We love our programming, we love our system design, we love software engineering. And yes, if you are interested in architecture, check out the architecture channel and on Rand's leadership Slack. Join the Slack. Um, anyway, yeah, that's the story. It's just such a great place. And what was I going to say? Somebody today, so we listened to the latest episode of the Staff Eng podcast, and we can Google for Staff Eng. So, oh, what's that? Plex. Oh, I just bought Plex too. But anyway, Staff Eng podcast. Staff Eng, and we have a podcast on the Staff Eng. And so it was Josh Catterlin, who works at Lob, said that for his career, the what did he say? For his career, the Rand's leadership Slack has been like a cheat code, because you can go in there and you can be struggling with some question about, oh, how do I deal with, how do I convince my boss that we should split the architecture into multiple components or something? And in like an hour, there's going to be 5 people who have done it before. It's like you have the best, highest quality, smartest coworkers in the world, but you can't get fired, and you don't lose them if you change jobs. So it's like, just, I love that place, man. I love that place. I love that place. It's really cool. I think Rand's has an article. 4 of them will be questions asking you why you think that they should. Why they should be split. Well, right, but that's good too, right? Like, it first of all challenges your beliefs, and then you say, oh, why do you have to split them? Maybe you can save time. It's really good, like, because even that's part of, they say, just, yeah, that's right. It's not about, it's like, and it's just not it's not like Stack Overflow, right? That way, where they give you the answer that you answer to the question you asked. They push you. They push you in the right ways. And, when I'm there, I try to do it too. But they push you in the right ways to make you justify your and insight. They make you justify your position. And if you have a good position, somebody will say, oh, yeah, so say this, say this, say this, try and present it like this. And so it's just such a wonderful way to level up and improve. And my whole channel is about leveling up and improving. And so I have no question that people who are interested in this would probably derive a lot of value out of that. And anyways, that's my pitch for the week. I'm in love with the place. It's like, just, wow, how good is it? How good is it? And they're all so nice, and they're so lovely, and so smart, and da. So there you go. That's my pitch. That's my pitch off the back of Josh Catterlin's from the Staff Eng podcast today. Anyways, that is the week. Big things coming. I've got that great interview coming out. I'm so excited. It's so good. Editing job was phenomenal. And in 2 weeks, we will go to chapter 22 and 23. And next week, I get the week off because it's Thanksgiving.